LeetCode 987, vertical order traversal of a binary tree. So this might just be the easiest hard problem on LeetCode. Okay, so let's look at an image to understand what the problem wants. So here you're given a binary tree, and what you need to do is you need to output a list of lists, and every element of the output should be the list of nodes that are on a certain x coordinate. So the first element is all of the elements of the tree that have the x coordinate of -1. So you can imagine the tree on a grid with the node, the origin being 0, 0, the root, and then you move to the left and downwards. So your y coordinate has become 1 and your x coordinate is -1, right? And the opposite is true here. Your x coordinate has become 1 instead of -1. Okay, so here are all of the nodes with coordinate -1. Here are all of them with coordinate 0. So you have 3 and 15. And then you have all of them with x coordinate 1, 20, and x coordinate 2, 7. So if there are multiple nodes on the same x coordinate, you just put them in order of top to bottom. And if there are nodes with the same x coordinate and the same y coordinate, like in this case, then you just sort them based on their values. So here you have 4, 2, and then you have 1, 5, and 6. And 5 and 6 are on the same y coordinates, so you just sort them based on their value. Okay? So yeah, that's literally all there is to this problem. I don't know why they considered it to be hard. So yeah, you just do a normal visit of the tree, and it's a normal recursive visit. So you just check if you don't have a node. So this is your base case, so you just return. Otherwise, you have your recursive cases. And in the middle here, or at the top or at the bottom, you can do some business, right? So this is just how you visit a tree normally. Okay, and now what you want to do is you want to also keep track of the coordinates. So we keep track of the x coordinate and the y coordinate. So anytime we call a recursive, we need to update those accordingly. So here we're moving to the left, so we are decrementing the x coordinate by 1, and we're incrementing the y coordinate by 1. Because like when we move downwards, we consider that to be y increasing, right? So the direction of increasing y is going downwards, okay? And the opposite for the right node. So you increment x by 1 because you're moving to the right, and y obviously still goes downwards. Okay, so this is how you keep track of the coordinates. And now you can have a map. We'll call that map levels, and you can push all of the nodes that are on the x level, on the current x axis, to these levels of x, right? So we push an object that represents our node. So we just have the value of our node and its y coordinate, like this, okay? And now we'll just make a map. So this is the map that is going to store, for a given x coordinate, the list of all of these objects that represent our nodes. So their value and their y coordinate, right? And this is just saying, okay, if there's nothing in levels of x, so levels of the current x coordinate is undefined, then just have a default value of empty array so that we can push to it. Otherwise, we would be getting undefined property push, cannot get property push of undefined, because levels of x would be undefined. Okay. And so now, yeah, at the end of this visit call, all of these levels are going to be populated. So in the levels map, you're going to have like, for example, here, you're going to have, okay, -1 has 9, and then 0 has 3 and 15, and then 1 has 20, and 2 has 7. And now all you need to do is sort them based on what the problem says here, right? So you want them top to bottom, ordered from top to bottom. So biggest y coordinate comes last. And if they are on the same y coordinate, then sort them based on their values. So that's all there is to it, all that's left here. And don't forget to map every node representation to its actual value, right? Because we don't want to return objects. We want to return a list of lists of integers, not of objects, okay? So yeah, now we just have a result variable, and at the end is just an empty array. And at the end of the algorithm, we just return it. And then we have a for loop that goes through all of the possible coordinates. And here we know that they are from -999 up to 1,000, because we know that the number of nodes in tree is at most 1,000. So starting from the coordinate 0, you could go, if you went all the way to the left, you could go at most up to this. And if you went all the way to the right, you'd get at most to 999. Okay, so now what we do is we take all of the nodes representations that are on that coordinate, right? So these are the elements. And then if there are any elements, so there are any nodes, because it might be that there are no nodes, like for example, in this tree here, let's say this example here does not have any nodes with coordinate, with x coordinate minus 999, right? So if we do have levels, so there's an array here, then what we do is we add to our result, so we push to our result the level at the current coordinate, but first we sort it based on the y coordinate first, like the problem is asking us, right? We want them top to bottom. And if this is equal, so this will be 0. Then if this is equal, we want to sort them based on the value, right? So this is how you use the OR operator in a smart way. So if this is 0, this is not going to be considered, and this is going to be considered instead. Okay, and then now we have achieved the ordering that we wanted, but now you need to map every element, every representation, every object to an actual value, right? And so you just do .map. So you map every value to every representation, every object to the value property, which has the original node value. And yeah, that's it. I'm going to submit the code to show you that it works. And the time complexity here is O of n log n technically, because you're using a sort here, but I'm pretty sure that without much effort, one could make this even O of n, honestly. And yeah, and the space complexity is O of n as well, because you're keeping one object for every node in the tree. So yeah, that's it for me today. Thank you for watching, and bye.